Hello everyone, this is Aheli. I am from Group 8 and today we are here to present how to prevent pollution in textile industry and how to practice waste management in that industry. So, considering the employment and production, it is one of the largest industries all around the world. In textile industry, water, fuel and chemical are consumed at a high quantity, which generates waste. Water pollution is the main environmental problem associated with this industry due to the discharge of untreated effluents followed by the presence of volatile organic compounds as well. The chemicals from textile industry includes acids, alkalis, detergents, dyes and salt. And the characteristics of effluents discharged from the industry varies from mill to mill depending on the amount of water that is consumed and how much product is generated daily on average basis. Next comes about the waste characterization. So in textile industry, the effluent generated is one of the greatest sources of pollution, and thus a strict permit for effluent discharge has been put into effect. The dye bath have large amount of VOD, COD, fibers and toxicity as well as heavy metals. So biological treatment process might fail if metals and dyes are present, which will inhibit the microbial activity. Textile industries have fiber residues that are high in VOD and which can contaminate water. Due to dyeing, copper, zinc, and mercury can mix with water. And dyeing also utilizes different sulfur containing chemical when it is converted into sulfide from BOD of the effluents. The oxygen that is present is removed as hydrogen sulfide can form poisonous gas. Though color is not included in the environmental conservation rule, but this also adds up in the effluent and it is visible unlike other pollutants. In this table given, it is mentioned that the different process that is being utilized in the textile industry and the effluent composition of each of the processes and the nature of the pollutant that is present in each of these processes. Thank you.
Coming to the waste minimization techniques, waste minimization is an idea of reducing the waste generated in industrial processes. So we try to reduce waste generation at the source instead of treating them at a later stage. So this is the waste minimization hierarchy from the most favored option to the least favored option. We start with prevention, minimization, reuse, recycling, energy recovery, and then disposal. So the first three are the most favorable and most useful methods as they come with uh, practically low costs, and recycling comes with a cost, and even those which are not possible to be recovered in the first four steps, we finally treat them in a waste treatment plant. And the least we could do is energy recovery. So if we incinerate a waste, we get heat that can be used as energy for other processes. And the last resort would be disposal. If you are not able to treat the waste at any stage, then we plan to dispose. uh, the main goal of the modern industry should be zero disposal to the environment. So this is the cost analysis of some of the process changes and their payback periods. The first would be to monitor reprocessing rates and manage them efficiently. This comes under the topic of avoidance, so practically no cost and payback period is immediate. And reduce the fabric used for qualities. We there is a reduction in usage of raw materials, and thus there is a reduction in generation of waste. The third step would be to reuse cooling water in scoring and dyeing process. This requires a modification in the processes and comes with a cost, and the payback period is around 2 years. And proper management of and inventory stock rotation. So inventory management is a separate domain, and efficient management of inventory can save a lot of costs. This comes with a little bit cost of implementation, but it will be the payback period would be immediate, and so it is worth investing in this. Waste fiber reprocessing using shredders and reuse them for spinning. This comes under the concept of recycling. You require a separate facility for recycling the waste products and then reusing them. So this comes with the cost, and the payback period is around 3 to 5 years. Installing a wastewater system to recycle wastewater in situ. In situ means we try to um, treat the wastewater in the same place as where it is generated. So this requires an additional facility, and practically it is a very expensive process, and the payback period is greater than 5 years. So this cannot be afforded by all industries. And so we try to improve the efficiency of processing streams and to reduce wastewater generation instead of treating them. By following these methods, we could be able to achieve the idea of zero discharge, and modern industries implement these methods to improve the efficiency of waste management and reduce the waste generation.
Now we talk about the alternative waste treatment methodologies used in the textile industry. First one is biodegradation. It involves 3 steps, which is biodeterioration, biofragmentation, and assimilation. Biodeterioration is the physical deterioration by mechanical or chemical means, or by the use of a UV radiation. Biofragmentation is when the particles, microbes attach to the surface and then begin to disintegrate it. Assimilation is when the disintegrated particles begin to generate energy. Coagulation, flocculation, it is the treatment, it involves using a component that basically from clumps of the pollutants, and then they can be removed by further filtration. Adsorption, it is basically a surface phenomena wherein an adsorbent is used and to absorb the particles on the surface, and which are then separated out by additional processes. Electrochemical methods. These processes involve the transfer of electrons and between 2 phases through the passage of electricity. This is the most efficient process, and as it has no sludge formation whatsoever, and it is usually succeeded by a process like adsorption. Membrane process. This process involves the separation of particles based on size. So what happens is it is also based on the use of pressure. So different size of particles are separated based on the type of filtration used, which is microfiltration, ultrafiltration, and nanofiltration, which, as the name suggests, is based on these following sizes. The membranes used are basically semi-permeable membranes, so that to allow the passage of not allow the passage of pollutants. The best method identified by our group is would be biodegradation, because of its many advantages, including low setup costs, easy acceleration and deceleration, so the speed can be controlled with respect to our needs. Multiple systems can be used in parallel, and it also generates electric energy, which can then be used to power the entire biodegradation process itself. It can be used as a standalone system, and it does not need any other dependent systems with it. Thank you.
So as we have mentioned above, all the waste from the textile industry is passed through a series of filtration processes so that maximum energy can be reused and there will be minimum amount of waste. That is done in effluent treatment plant. So in our proposed design, there is an effluent treatment plant where the returned waste is separated into 3 categories: into recyclable materials, bacterial degradation, which is done for azodite materials, which contains a lot of chemicals, and biodegradation is done to all the other materials, and the energy is recovered, and the rest of the effluent is transferred to the effluent treatment plant, where it is treated for the maximum retrieving of the energy. So from this, there is a final effluent that is going out of the industry, and this final effluent should be treated so that it won't be harmful for the environment, and so that we can receive a lot of energy and the waste will be minimized. So in a case study that was done in Bangladesh, The final effluent disposal is done in such a way that the effluent is converted into fertilizer. When we look into it, the soil before sowing the seed and the soil after harvesting the crops, they have taken the soil samples and conducted studies on them to find out the difference between them. So, as we know that the effluent or the waste from the textile industry is high in pH and it contains a lot of nutrients and phosphorus and nitrogen and other minerals which are mandatory for the plant growth. So we can use this in a successful way as a fertilizer. And the gaseous effluents are sent back to the atmosphere or the ecosystem after treating for the metallic poisoning and all the other poisoning or particulate matter. So this is how the final effluent is treated in our proposed design. Thank you.